in this section, we're talking more about radical expressions. So let's talk about properties of radicals. Now, if you have first of all, if you have two radicals that you're multiplying, right, and they have the same index, so the square root of 2 times the square root of 8, you can combine them. You can multiply the 2 and the 8, and it becomes the square root of 16. Or if you have the cube root of 3 and the cube root of 9, right, the cube root and the cube root are identical, you can multiply the stuff inside and it becomes cube root of 27. Once you have that, you now have to try to group the factors of 27 or the 4. So for example, if you have the square root of 16, well, what's 16 made of? It's 4 times 4, right? And then technically it's 2 times 2, and then it's 2 times 2. And since it's a square root and the index is 2, we always group everything by pairs. So this comes out as a 2, this comes out as a 2, the answer is 4, right? You group them by pairs because it's a square root. Now, what if you have the cube root of something, cube root of 27? Well, now 27 is 3 times 9, which is 3 times 3. Since you now have a cube root, that index is 3, you have to group the factors by 3's. So here you group them by 3's and they come out as a single 3. That's why the cube root of 27 is 3. All right? So if you had the fifth root of something, what would you group them by? 5's. All right, so let's take a look at how we're going to do this one. So I have the square root of 12c to the 6 d cubed. Okay, we do each element independently of each other. So first you take care of the number, the 12, the coefficient, then the c, then the d. So let's do the 12. 12 is 4 times 3, which is 2 times 2. So it's a square root. That means I'm going to group by 2's. So 1, 2 comes out. The other stays in. All right? Now the c's. If it's c to the 6, how many c's are there? 6 of them. So let's just write it for the first time. Okay? I'm going to group them by 2's. So how many come out? C times C times C, C cubed. All right? So this one comes out as a C, this one comes out as a C, that one comes out as a C, and it's C times C times C, C cubed. Okay, what about D cubed? What about the D? You have D times D times D. You group them by 2's. That one comes out as a D. Well, what about the other one? It stays in because he's got no partner. So 1 comes out and 1 stays in. All right, and at the end of the day, that's your answer. Okay? Now, I'm just going to circle this for now, and then I'm going to come back to it actually. Well, I'm going to put a box around it. Okay, so let's do this next one. I have the cube root this time of 27. We just did the cube root of 27 here, right? And we said it was 3, so can I just write the answer this time? Now, the y to the 4, right? I have y times y times y times y. Group them by 3's. It comes out as a single y. And what about the other one? It stays. So this time, so one y comes out. The other one is going to stay in a cube root. Right? If you start it with a cube root, this has to remain a cube root. What about z to the 7? Those are 7 z's. So group them by 3's, group them by 3's. How many come out? 2 come out, z squared, and that poor z has no partners and it stays. Now, okay, so this is fine, writing them out. But what if you have like the cube root of z to the 64? You're not going to sit there and draw 64 z's. There has to be a more efficient way. Divide by 3. That's a good way. What then? So, okay, so let's just, find the remainder. Okay, let's do this. Let's do this then. So here we have y to the 4, right? Y to the 4. What's the index? Here, it's a 3, right? So what if I did 4 divided by 3? What would that give me? What remainder what? It would be 1 remainder 1. That means 1y comes out, 1y stays in. Now let's do the z. You would do the 2 separately, right? The coefficient you would have taken care of separately. Okay? So it's z to the 7. What am I going to divide the 7 by? 3. So 7 over 3, that's 2 remainder 1, right? 2 remainder 1. 2 remainder 1. That means, look, 2 z's come out, 1 z stays in. Okay? And you can do it for z to the 5,237 even. Okay? Yeah. The 7 is given. There was z to the 7. So just divide that number by that number. 7 divided by 3. 4 divided by 3. Okay, so we divide that number by that number. 7 over 3. Well, if you divide 7 over 3, 3 goes into 7 twice. And there is a remainder of 1, right? So you got 2 remainder 1. That means here you get z squared, which is 2. And inside, the remainder is the number of z's that stay inside. So this is the number that comes out, this is the number that stays, right? That remains, right? Get it? Remainder, remaining. Okay? All right. Questions?
Yeah, wait, what is a remainder?
Now, when we're dividing, when you have a fraction in a radical, you're allowed, in a case like this, you're allowed to split it up. So the one in the numerator gets a root, the one in the denominator gets a root. So for instance, if you have the square root of 27 over 4, you can split it up to root 27 over root 4. And then you simplify from there. Okay? So let's do this one here. Let's do this one here. The minute you see one like this, you just split it up. So this is the square root of y to the 8 and the square root of 9x. All right? Now, this in the numerator, right? It's what? It has an index of what? 2. It has an index of 2, so I'm going to divide 8 by 2. So it'll be y to the 4. No remainder, so they all come out. Y to the 4. Now, over here in the square root, I have a 9 and I have an x. I do the 9 separately. Ignore the x. What's the square root of 9? 3. And then I have the square root of x. Now, can I do anything about the square root of x? Not really. But can I also leave it in the denominator? No. So what do I have to do? You have to multiply top and bottom by the square root. Now, what is that process called? This process, what is that called? If you have like root 2, what kind of number is that? It's an irrational number. So when you get rid of that, you rationalize it. So this is called rationalizing. All right. So here we're going to get y to the 4 root x. And on the bottom, I get what? 3 times, what is this? Root x times root x? Just x. Y, root x times root x, it would be the square root of x times x, which is what? x squared. And what do a square root and a square do to each other? Get rid of one another, okay? All right, let's do this next one. I have the cube root this time of 2 over the cube root of 9x. Now, can I do anything about the cube root of 2? Not really. Okay, what about the cube root of 9? Does that? No, that doesn't work because 9 is just 3 squared, and the cube root of x, I can't do anything. But now I'm left with this root in the denominator, which I don't like, right? So I need to get rid of it. Now, in order for something to come out of the cube root, how many of them should there be? 3 of them. So let's just see what we do have. This is the cube root of. What is 9? It's what to the power of what? Huh? It's 3 to the power of 2. And then I have an x. Okay, now look. 3 squared, right? How many additional 3's do I need to make 3 of them here? What? Okay, how many 3's are there in the root? There are 2. How many additional ones do I need to make 3? 1 more to make 3. So now I'm going to add 1 more. The way I add is I do this. Cube root of 3. You see how you multiply root x, in order to complete it? Here I'm going to multiply cube root of 3. Cube root, because this is a cube root. And now I have 2 of them in here. I need to put in 1 more. Now, let's move on to the x's. How many x's are in this root? 1. How many more do I need to make it 3? 2 more to make 3, right? So I put in 2 more x squared. Now I'm going to multiply the same thing here. Okay, now let's see what we have. Okay, who's confused here? Okay, so here in the numerator, I have cube root of, I multiply the 2 times the 3x squared, 6x squared. In the denominator, I have the cube root of 3 squared times 3 will be 3 to the what? 3 squared times 3 will be 3 to the 3rd. And now I have x times x squared, and it'll be x to the 3rd. So this is cube root of 6x squared over 3 times x. Now,
Oh, why don't